All right, so today is the second part of the lesson. Excuse me. This is the last lesson for the week. We'll be combining for our review tomorrow these concepts, a little bit of factoring, and last week we were combining functions. Remember, we were adding functions, multiplying them, dividing them. Okay. So this is the last little bit we have to add for our little section here. Yesterday, when we had a vertical shift, all we do is take the function and add our vertical shift, our k value to it. Okay. Today, instead of, so yesterday was vertical shift. You see how this is y is equal to x, and then we move it up or we move it down. That's vertically shifting it. And for today, we're doing a horizontal shift. So instead of applying it to f of x, which is our function, which is our y value, we're going to apply it to our x value. So it's getting a little ahead of ourselves. But today is just moving it left to right. Yesterday was up and down. Okay. Now, this function right here, this function, y is equal to x, is the very, very basic line. It's the parent function for any line. It's really just modifying this line to be in a different position. So you could think that every linear function you could think of is really just this parent function that goes to the axis, right there, goes to the origin. It's this parent function manipulated, turned, moved, flipped, moved up and down, left to right, but it's really just how we're going to manipulate this function. If you can really think of it that way, then all linear functions are kind of the same thing, just with in a different position, right? It's just a line. Here is the line. This is like the grandfather of all lines. And then we can move them up and down, left to right. We can flip it. We can do everything. Okay. Now, looking at this, here is my parent function, y is equal to x. Y is equal to x. What am I doing if I move it up here? Up. Up how many? 2. You can look at the y-intercept moving up 2. So this is just a review of yesterday. If I move this function up 2, essentially what I'm doing is the f of x, my y value, I need to add 2 to it. Since y is equal to x, this one is going to be y is equal to x plus 2. I want you to put it down here. What is this function going to be? We took our parent function and we had to essentially move it down, vertical shift down. So make the function for this bottom dashed line. What's that going to be? So look, it's always going to be, you're given a function, here it's y is equal to x. So if we move it down 3, we just have to apply that minus 3 to the function. So, Grace, what'd you get for the bottom dash? Good. It's a -3 shift, so it's just y is equal to x. It's the same function. We just minus 3 from it. It's off at the end. It's not connected or within the x value. It's just y is equal to x, minus 3, and then that's moved down. Now, if you look at this, this is our y-intercept, right? -3. -3, y-intercept. The slope is 1 over 1. Right? That's 1 over 1. Okay. It's a 45-degree angle if it's 1 over 1. All right. Thumbs up, sideways down for yesterday. How do we feel about it? Pretty good. Now, today is different. Today is a horizontal shift. Yesterday, we were applying the vertical shift to the y component. What do you think we're going to apply the horizontal shift to? What's side to side? X. Okay. We're going to apply it to the x. Now, this is something you got to remember. For Thursday, I hope you box this out. I want you to write next to it, remember this. Okay? Remember. Because this is really the only thing. Maybe you got to remember this as well. But these are the only things you got to remember for the quiz Friday. There's no notes on the quiz. So I need you to be ready for that. You got to memorize this and maybe memorize how to do an easy problem like this. Okay. So if I have this equation right here, right? And I'm shifting it plus 3 to the right. The plus 3 goes in for my k value. So now it's instead of, say if it was this, if it was f of 2, or if it was f of x is equal to 2x, what if I did f of 2? What am I going to do with the 2? Remember, the left side of the function just tells you what you're doing. The left side is like a map. It tells you what to plug in. It tells you, if you're looking for the inverse or whatever. So here, f of x equal to 2x. F of 2 is equal to, where am I going to put that 2? Yeah. It just tells you what you're plugging in for 2. Okay. Excuse me. What you're plugging in for x. It's 2. So f of 2 equals 4. You guys can do this, right? You remember that part? Okay. So remember, function notation, the left side is just telling you what you did or what you have to do. So if I'm setting this one up, since this is our x value that we would plug in everywhere there's an x, and this is our horizontal shift. With a horizontal shift of 3, I just have to plug in the 3 right here, simplify those signs, and essentially what we have is plugging in the x plus 3, or x minus 3, excuse me. We're plugging it in for x. Plugging it in for x. So that is, the expression fits right there. All right. I think step-by-step example 1 is going to help us more. Okay, so let's look at example 1 real quick. So since I know I'm doing a shift, shifting the function -8, that's to the left towards the negative values. Now watch what I'm going to do. I'm going to set it up. I'm going to set it up on the left side to remind me what I'm doing. I'm shifting it -8 to the left. So I always set it up with this setting, f of x minus k. So f of x minus k. What is my k value? Go ahead and input your k value right here, and then check with your neighbor. What's going to be inputted right here for this problem, right here? We're doing this problem. So it's just whatever that k value is. Tell your neighbor, what is it? What goes in there? Jordan, what should I put in there? -8. Yeah? So this works out to be what? X plus 8. Now, here's the thing. Once you know what you're plugging in, just like before how we had f of 2, and that told us that, what do we have to put there? 2. I don't care if it's 2. I don't care if it's star. You're going to put the star. You're going to put the 2. You're going to put the expression exactly where that x value was. Okay. It's like, I'm trying to make it abstract here to show you that I don't care what is in there. So what is in there? Instead of x, what do we have here? X plus 8. So watch. Where there was an x, I'm going to go ahead and put x plus 8. The left side of the function does not change. It just tells us what we did. This was a shift -8. It's always x minus h. So since it's x minus -8, it becomes the plus 8, but that's just working it out. Over here, I'm going to go ahead and distribute 2x plus 16, and that's our answer. All right, really, we just got to do these. I think we should do these back to back. You'll see it a couple times. You'll see how we connect. Here's our next one. A shift, +1. That's going to go to the right. Let's set it up for our shift, x minus whatever my k value is. I said h, but it's the k value. And actually, let's just figure out what are we doing here. Let's see, what's a shift? +1 because it's to the right, right towards the positive numbers. What do you think I should put right there? 1. +1, 1. So when I simplify that, it's x minus 1. And then I look here, and here's where the x was. What should I put in there for the x? X minus 1. You see, it doesn't matter what, if it's a function of x squared minus x plus 17, you put that whole thing in where the x was. Okay. So x minus 1. That's our answer. I think we just got to keep doing a few. Okay. Thumbs up, sideways, down at this point. Give it to me. In the middle. Up, sideways. Double up. Let's do this bottom one first. Example 4 first. Example 4. So it looks like it's a shift -5 left. So I'm going to set it up. And people at home are like, what? What's he doing? I'm going to go x minus some k value. 5x plus 8. Go ahead and put in whatever our shift is. You guys see that if it's to the left, it's negative. That's towards the negative numbers. Okay, so I put -5, and that's to the left. But if they say it's a shift to the left negative, or shift to the left 5, that's negative 5 still. Okay, so keep that in mind. You might see that. All right, Joe, what goes in there?
Negative 5.
Negative 5. I simplify that to be x negative times a negative. So I want you to put in what you think goes in there for x now that we know kind of what we want to substitute. Left side of the fraction just telling us what we're doing. Excuse me, left side of the equation. All right. And check with your neighbor. Check with your neighbor. Yes. All right, how are we looking? All right, Alejandro, what goes in there in the parentheses?
5.
Almost. Someone help him out. Yep. X plus 5. Remember that we were setting it up for the shift. We were deeming this negative times negative, so we know that we plug in f of x plus 5. We're going to plug that whole thing in over here. X plus 5. Distribute that 5. We get what? 5x plus 25 plus 3. Is there anything we can combine there? Yeah. 5x plus 28. So there might be a little distribution in there. Don't sweat that. Just distribute it. Okay, this last one, maybe the hardest one we got to do. There's something extra we have to do here. First, what is different for example 3? There's 2 terms, and there's an x here, and an x here. Okay. So if this function, if I said it's f of 2, what would I do with that 2? I'd plug it in where? Here, and there, right? So we're setting it up to be a shift instead of just plugging in a number, but we're going to apply it the same way. I'm going to go ahead and do x minus negative 3. So that ends up being x plus 3. And then what am I going to plug in on the right side? Let's see. Go ahead and do it. Distribute it. Make it look nice. So set up the left side of the fraction, or function first. Function notation tells you what we're doing. And then go to the other side, plug it in. All right. All right, and now it's about time to check with their neighbors. What did they end up with? Okay, Kim, help us out. What goes here and here? X plus 3. Looks like we got to distribute a little bit. Okay, Joe, help me out. Distribute the top. This top of the fraction is
2x plus 6.
Good. And Richard, help me out here. Distribute this for me.
7x plus 10.
Okay. And you could work really, really hard to combine all those terms, but I'm going to let you. That's a different lesson. So I'm going to let you go ahead and keep it like that. Raise your hand if you got that. You got that. That's pretty good. That's pretty good. Last one. I'm I'm just going to write it this way. Don't get confused. What does this mean? If I say shift left 10.
-10.
Got it. You guys are good. 1 over x plus 1 or plus 4. Plus. Last one. Set up the function part, the left side of the equation first. Alright, since it's going left, I'm going to put my -10 there. That makes it x plus 10. Looks like I'm going to have to plug it in here. And maybe over here. Let's go ahead and do that if it didn't. You already got it. Raise your hand if you're done with the problem. Yeah. About half this. Good. Put it here. We're going to be able to combine some stuff here, though. If you didn't do that, make sure you do it right here. Combine stuff. You can combine it. That grouping in the parentheses doesn't have to be grouped. You can drop the parentheses if you can combine. So do it. Evelyn, what happens when we distribute that 5? And which terms, Teresa, which terms can we combine here? Alright, so we're going to get x. Alright, I label it because it is that shift. Stay. Raise your hand if you got that right. That's good. All right, you guys did it. I'm going to give you this like 20 minutes to do 11 problems for homework.
What about that track high school?
Let's see how you guys work. Let's see how you guys work on this.